Hello friends, in this video we are going to study buoyancy, metacenters and condition of stability for a floating and submerged body. So first of all, what is buoyancy? So buoyancy is defined as an upward force exerted by the fluid on the body when the body is immersed in a fluid. Means once we are trying to immerse any body in a fluid, the fluid exerts some upward force on this body, and the magnitude of this force is equal to the weight of the fluid displaced. So whatever the weight of the fluid which is displaced by this body, the magnitude of this force is exerted by the fluid on this body, and this force is called as buoyancy. So then what is center of buoyancy? So center of buoyancy is the point through which the force of buoyancy is supposed to be act. Means the force is exerted on the all faces of the bodies, but for the simplification purpose we will consider it is acting through a single point. So this point through which this force is supposed to act is called as center of buoyancy. So center of buoyancy is basically vertical force, and it is equal to the weight of the fluid displaced by the body. So whatever the force we have already seen in the definition of buoyancy, so magnitude of this force is equal to the weight of the fluid displaced. Now what is metacenter? So metacenter is basically a point about which a body starts oscillating when the body is tilted by some angle. Means when there is a floating body, if we give some small angular momentum to this body, then the body will start oscillating in that fluid, and at the point at which this body start oscillating is called a metacenter. So metacenter can also be defined as the point at which the line of action of the force of buoyancy will meet the normal axis of the body. This meets at this point M. It is that point at which these two, the normal axis of the body and line of action of the force of buoyancy, will meet. In this diagram we can see there is one floating body. This is the floating body. If we give it some angular momentum in clockwise direction, then this center of buoyancy, obviously center of gravity will remain at the same point, so this force will be at the same point, but this center of buoyancy is what we have studied. Center of buoyancy is the center of gravity of the displaced fluid. So displaced fluid in this case is that much. Obviously this portion is larger, so the point, this center of buoyancy point, will shift to the right, and this is represented by this point B1. So now this center of buoyancy, buoyant force, will act through this point B1. Now if we draw this B1 at this point, it will act in vertical upward direction. If we draw a line which will meet this normal axis, it will meet at point M, at this point M, this M point at which the body will oscillate through this angular displacement. It is called as metacenter. Now what is metacentric height? The distance mg means the distance between the metacenter of the floating body and center of gravity of the body is called as metacentric height. Means this distance, this mg distance is called metacentric height. So it is the distance between the metacenter and center of gravity of the body. And now the condition of equilibrium of a floating and submerged bodies. Means to be in equilibrium condition, there must be some conditions. Means what is the place of the center of gravity, center of buoyancy. According to that positions, the body is said to be in stable equilibrium or in unstable equilibrium or in neutral equilibrium. So firstly we will consider two types of body. There one is submerged body and the other one is floating body. For the completely submerged body, means body which is completely submerged in a fluid, we have considered an example of balloon. This balloon which has a center of gravity at this point, means as we have shown in this figure, there is a heavy portion on the bottom side. Due to this, the center of gravity is below the center of buoyancy. So in this point, if we give some angular momentum in clockwise direction to this body, then the center of gravity will remain at this position. Then the center of buoyancy will shift like this. We can see there is a couple which will act in counterclockwise direction. We have given the angular momentum in clockwise direction, but couple is acting in counterclockwise direction. Means the body tends to be stable. Means if we give the angular momentum in clockwise direction, body automatically gives the anti-clockwise momentum and makes it stable. But opposite to that, if the center of gravity is above and center of buoyancy is below, like in this B diagram, then if we give the clockwise momentum, then it will form a couple which is acting also in clockwise direction. So obviously what will happen? The body will overturn and the body will not become stable. And in the third case, if the center of buoyancy and center of gravity both are at the same point, then there will be a neutral equilibrium. Obviously there will be no any such couple will be acting on the body, and the body will be in neutral equilibrium. But opposite to that, there is a stability regarding the floating body, which is partially floating, means partially into the liquid and partially into the air. So in this body we can see, in this case we will consider a metacentre. In this case, as we have seen, what is metacentre, what is metacentric height, the metacentre comes into account during the stability of the body. So here is G, acceleration due to it is the center of gravity, and B, which is the buoyant force, center of buoyancy. Now if we give the clockwise angular momentum to this body, then this B point, means this center of buoyancy, will shift to this B1 point. So this B1 point obviously will meet this axis of the body at point M, which is called as metacentre. If this metacentre is above, if this metacentre, as this in this case it is above the center of gravity, so obviously at this metacentre the force will be upward, at center of gravity force will be downward. It will form an anti-clockwise couple and the body will be in stable equilibrium. But in the second case, as the center of gravity is above, center of buoyancy is below, in this case we have given it angular momentum in clockwise direction. Here center of buoyancy shift to this point B1, but is this point B1 meets with this axis at point M, which is metacentre, but this metacentre is now below the center of gravity. Due to this, what happens? Center of gravity acting at the right and metacentre will act at the left. So it will again form the same clockwise couple, and already we have given the clockwise force. So it will overturn the body, means the body will not be in stable equilibrium, body will be in unstable equilibrium. And the third condition, again, if the metacentre and the center of gravity are at the same point, then there will be a neutral equilibrium. Okay, there is no numerical treatment on this in the exam, so only theoretical point of view these concepts are important.